Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 11th. First, we look at significant seas for the North Pacific Ocean. We see a small area here, seas associated with Tropical Storm Nora, southeast of Hawaii, not really of interest except for anything but the south and east shores of mainly the Big Island. Another area of fetch here associated with generic low pressure, somewhat associated with a major westerly wind burst that's been going on in this area. And also secondary fetch up here in the Gulf of Alaska from a previous gale that was up here that produced swell that is hitting California at this point in time. Surf heights were up to the 10-foot face size in the San Francisco Bay Area today, Sunday, and that is working its way towards Southern California. Let's start diving into the details. We have much to cover tonight. As usual, we'll start with the upper level picture. Jet stream level winds. These winds up about 30,000 feet help support the formation of storms. When those storms do form, these winds help direct their track. Currently, we have a bit of a split flow coming off Japan. Notice a stream up here going through the Bering Sea, but the main energy here is coming off Japan. A bit of a ridge forming here. This does not support gale development. And then they finally consolidate over the Gulf of Alaska and push into British Columbia. No real troughs. If there was a trough, it would be right here. That is a bow to the south that would support a counterclockwise circulation in the upper levels of the atmosphere, and that also would manifest itself as low pressure lower in the atmosphere. Also of note, an upper level, this is more a peculiarity, not really surf related, but interesting just the same. Upper level low here, this low previously worked its way on into Central California last week, worked down south of Baja, is working its way off the coast of Baja, and if you keep your eyes on it as we push through the chart, you'll see where it's going to go. Very just kind of a abnormality. You don't see this sort of a situation very often. Anyway, so we put this into motion. We notice a good amount of energy here in the jet, but again, the split thing is not helping this. This isn't a trough here because it's cut off up here at the top. Still, we'll call it sort of a pinched off trough, if you will, but it's not going to support gale formation of any kind, really, until here on Tuesday night. Notice the upper level thing pretty much dissipates. Now we have this steep pinched off trough. Also, the Baja system is working its way off to the northwest, off of Southern California by Tuesday night. We'll just roll this a little bit further. And then we go into Wednesday night, and this starts moving onshore over Central California. The trough here in the Gulf of Alaska starts digging out a little bit better. This is actually a very good sign. And notice the split pattern over here is all but gone. If it's split over Siberia, that's fine, as long as it consolidates as it moves off the coast of the Kuril Islands, we're fine. Anyway, so that starts happening, and then we roll this out, and notice the trough gets a little bit better organized. Not a whole lot of wind pushing down into it, but still a decent trough nonetheless. What is that? 130 knot winds at one point here on Thursday night into Friday. And then, whoops, we lost her. There we go. And that's sort of, the trough tries to push onshore Saturday here. The suspicion is there could be some weather associated with this for Central California and Northern California. And still, the pattern holds pretty much the same into the weekend. You know, and here we go again, yet another trough trying to dig out on Sunday. And this is looking very much like an El Nino sort of pattern. You'd expect a semi-permanent trough in the Gulf of Alaska. You'd expect pretty decent wind energy and mainly consolidated energy pushing off Japan, almost going flat across or to the east across the North Pacific and carving out a trough here in the Gulf of Alaska. And that's pretty much what's happening. And now, could you say this is El Nino enhanced? Maybe a little bit, but seeing how it's October, this is about what you'd expect for the time of year. But we suspect that there is some El Nino enhancement going on here nonetheless. Also, little bits of tropical activity even manifesting themselves high in the atmosphere here. We'll get more into that. The point being with this one here, if it's so close to the jet, the odds of it getting sucked up into it are pretty good, and then recurving off to the east. Next, we go down to the surface. High pressure over the date line, not pretty kind of normal sort of thing. Low pressure in the Gulf of Alaska, 45-knot winds here. This is actually part of a previous low that was up here last Friday or so. Low pressure that dug out again by a trough in the Gulf of Alaska, and now secondary low pressure creating 45-knot winds and seas pushing mainly into Canada and British Columbia coast, probably sideband energy all the way down into central California with luck, but nothing of any huge proportion. Tropical storm Nora here, our area of low pressure. Look at this kind of giant pool of low pressure. The equator's down here, the point being westerly winds at the surface working their way right in just, 5 degrees north, 5 degrees south, the Kelvin wave generation area. This is relative to El Nino. You want to see westerly winds in this area. They are fully in play. This is 15 knot. This is at a very gross level here. 15 knot westerly winds from, what is that, 145 east to the date line, and maybe a little bit beyond that. So if this was a normal year, and if the MJO, Madden-Julian Oscillation, was active, we'd say this is very good to help support storm formation. But no, this is the sort of thing that's going to go on for a long time. This is classic major El Nino sort of setup here. Major westerly wind burst, and that will be imparting energy into the jet stream at some point in time. Anyway, let's put this into motion. Continue on. The trough or the low up here in the Gulf dissipates by Monday. We watch Nora. 2 new systems are forecast to develop as a result of this westerly wind burst, and this is typically what you see. Westerly winds, you get this kind of an eddy thing going on, and you get, in this case, 2 tropical systems, unnamed at this point in time. We'll just let that roll. And also, remember, there was a trough trying to dig out here in the Gulf of Alaska on Tuesday. We see low pressure here falling. We see low pressure here. We'll see what happens here in the coming chart. But sure enough, there we get some development. 30-knot winds. We really need 35 to 40-knot winds. These 2 guys continue on Wednesday off to the west. Roll this out. Here we go. Nice, well-developed, not a super well-developed, but a good low-pressure system here by Thursday in the Gulf. Another one coming off of Kamchatka. We'll just roll this out some more. Here's where things get interesting. This guy makes westward progress and then stalls right here while this tropical system starts heading off to the northeast, and then another tropical system off here develops as well. And this is what's interesting. We have blocking high pressure to the north, so it's not going to be able to penetrate to the north, and it starts moving off to the east and very far south down at 30 north here. We'll just sort of roll this back, watch this track, this guy right here. Just go, here we go. And it just starts racing off to the east-northeast. And remember, we have this semi-perpetual low-pressure trough now setting up here in the Gulf. Roll this out a little bit more. It just seems at 180 hours, this guy's building momentum per the models. If he can tap some of this jet stream level energy, if the jet gets another good pulse down in here, maybe we could get some good solid extratropical storm development. We've been looking for that all year. It has yet to happen, but we suspect it's only a matter of time. Again, here's the models. We have 1, 2, 3 major tropical systems a week out. We'll believe it when it happens, plus low pressure in the Gulf. The atmosphere looks primed for storm development. And then finally, let's examine the effects of those winds on the ocean surface. Here we go. A little bit of 32-foot seas, 34-foot per the numbers here, but that's over such a small area. Good, and the swell window here relative to Northern California, it's basically out of the swell window. Anyway, and otherwise, just generic sort of activity going on, nothing of any particular interest. We'll roll this out. We're looking to see, here's the next gale, sort of energy trying to form in the Gulf, or I'm sorry, over the dateline, but not making it on Wednesday. Our 2 tropical systems down here. We'll roll this out, and here we go. Little area of 20-foot seas, aimed somewhat at Hawaii and at the U.S. West Coast, but over such a tiny area, probably doesn't mean a whole lot. And our 2 tropical systems here into Thursday. Now we saw, what was that? Let's go back there. Oh, that's only 18-foot seas. That's not enough. We want to see at least 20-foot seas. And here we go. Come Friday, a good area of 22-foot, maybe 23-foot seas, aimed right at the U.S. West Coast. Sideband energy pushing to Hawaii. Our 2 tropical systems here. there and yet a third over here. Roll this out. This looks very similar. Maybe not quite as strong as the gale that created the swell that hit North and Central California today, but still, this ought to be good for a decent pulse of like 13 or 14 second period swell moving into the U.S. West Coast, if it does what it's supposed to. And that guy fades out. Now watch this guy. He starts racing off to the east, and of course, and here's more low pressure building here, and that's where the model leaves us. A pretty nice picture. 1, 2, 3 tropical storms, low pressure in the Gulf. Certainly seems like fall is finally on the way. This is a step in the right direction. And we go to the southern hemi. We're going back in time actually to Friday the 9th. The point being there's a little bit of a gale here that pushed under New Zealand. 38-foot, 36, 38-foot seas sort of thing in this area. Probably good for another small pulse of southern hemi swell. But as we've seen this past weekend, the southern hemi swell that is working, that's in the water, pretty much will get buried as the North Pacific comes online. And now here we are at current 18Z on Sunday. We'll just run through this real quick. We're looking for any signs of more southern hemi activity. Something this size, this small, barely 30-foot seas, probably will not much register. There's a better gale forecast out on late Thursday, Friday, a tiny area of 40-foot seas, but notice this. It was almost looks like it's falling east-southeast, not really, but not getting good exposure to the north. Still, for Southern California, certainly for Tahiti, swell should result. And then we roll this out, and again, the general tone is a fair number of systems, but small and getting smaller, and those will just get buried by the larger, more local activity that's starting to occur in the North Pacific. And now let's go take a look, long-term, what is going on, and especially the focus on El Nino for 2015. So as usual, this is a 3-part presentation. The first focuses on winds and wind speeds and anomalies in the West Pacific, equatorial West Pacific. That pushes warm water off to the east, creates things called a Kelvin wave. Kelvin waves are pockets of warm water. And then we go examine the next part of our presentation will be subsurface, looking at what is happening below the equator down to 300 meters. And then finally, if Kelvin waves are in flight, when they erupt off the Galapagos area, then that warms surface waters, and then we'll start talking about surface water temperatures. Right now, the top image, actual wind speeds and surface water temperatures. We're not getting into that. The wind speeds is what we're looking for. We see normally in this area, like here, you see trades going the whole way across the Pacific. But between 140 and about 175 is an area we call the Kelvin wave generation area, 5 degrees south, 5 degrees north of that. If you have slack winds or out-and-out westerly winds, that can help create a Kelvin wave. That is, it starts pushing warm water that's normally here pulled up in the West Pacific Ocean, starts pushing it to the east, and that warm water falls to depth. Certainly, we have westerly winds in play in this area. And from an anomaly perspective, this bottom half of the chart shows differences in normal for this time of year at this location. Very strong anomalies pushing from west to east. This is a prime example of what one would call a westerly wind burst, and this is perfect for setting up a Kelvin wave. So we zoom into that Kelvin wave generation area. The equator's here, New Guinea here. We're looking the prime area. We're saying 3 degrees north, 3 degrees south, but we've also modified the chart as we told you about last week to extend it up to 5 north and 5 south. Westerly winds or westerly anomalies. This chart is GFS model just showing you absolute wind speeds and directions. If you had 3-knot westerly winds, we'd go, that's a really big deal. That's that's not just anomalies, that's westerly winds, because normally you have trades at 10 to 15 knots running through here from the east. And we clearly have up in here west winds in the 18, 20, 22-knot range here in the North Kelvin wave generation area, the entire length of the Kelvin wave generation area, and down into the proper area in this area here. This is very impressive and solid, and this has not been happening just for a day or two. This has been going on for the better part of nearly 3 weeks now. Let's put this into motion. This pattern basically continues, but then look at this, still strong westerly anomalies in the, what is that, 20 to 22 knot range on Tuesday. More westerly anomalies off here in the western part of the area, and this just goes on here. It's not abating 96 hours out. Okay, so the one area starts dissipating, but now here comes another area of westerly winds, not as strong, but still in the 15 knot range, and that goes on into, where are we? Almost the weekend, and then things settle down, and it turns into weakened trades in the heart of the Kelvin wave generation area. And even at that, I mean, these are, what are we talking about here? Maybe 5, 8 knot easterly winds. That's still anomalies. So, major Kelvin wave in flight, supposed to continue for the better part of the week and then finally die out towards the weekend. Let's put this in perspective. So a little bit of history here. By history, we're talking about late June, early July. Okay, now this chart shows deviations from normal in the Kelvin wave generation. Actually, it's for the whole planet, but we're looking at the area from roughly 140 east to about 170 west. So you draw lines right down here. This is the Kelvin wave generation area. And if you see these purples, and we could maybe drag this up here so you can see the scale. Here's the scale. The purples represent roughly 12 meters a second. That's the equivalent of about 24 knot westerly winds in the Kelvin wave, 24 knot anomalies in the Kelvin wave generation area. The point being, this was a major westerly wind burst that went from, the 25th of June till the 15th of July. So what's that, about 25 days in duration? And this made a massive Kelvin wave that is erupting now in the East Pacific. We'll get into that in a minute. Kelvin wave number 3. Now I want to show you something. Now here is the current situation starting, actually I'll drag this down. You can see here the 10th of September there were westerly anomalies in play, but it's really starting about, let's say about there. Actually, you can line them up and say, okay, so this guy got going good about this line. The current westerly wind burst about the same, little pulses here, and then major, and then this guy in the core here is somewhere in the roughly 14 to 15 meters per second, 30 knot anomalies maybe that's a little overhyped. But anyway, you take this westerly wind burst, we know it made a major Kelvin wave. Look at this westerly wind burst. It looks very much the same in terms of duration, aerial coverage, and position just west of the date line. You go, it certainly seems like another major Kelvin wave would be produced by this westerly wind burst. And think about this for a second. The Kelvin wave produced by this westerly wind burst, number 3, is just starting to erupt in the Galapagos now, and we'll get into that. And now right behind it, what is that, July, August, September, 2 months later, 2.5 months later, you have another major westerly wind burst. I can't imagine how much warm water is going to start piling up into the Galapagos. Anyway, this is a very good sign. This is classic major El Nino, and it is these westerly wind bursts that push warm water to the east, which then erupt on the surface, which then, as they start warming the equatorial East Pacific and Central Pacific, starts modifying the jet stream, and then that starts fueling storm development in the North Pacific in the winter months. So right now, things look incredibly well primed. And here we go. Here's yet one more view of that. Now, here, you can barely make it out. Here's Australia, the Philippines up here, Mexico here, and South America here. These are wind deviations from normal, and we're going back in time a little bit, but just another nail in the coffin. Westerly winds, major westerly winds on these images, more westerly winds, and this is all where normally you should have trade winds. So the wind pattern in the western Pacific has completely reversed itself, and the reality is this has been going on, maybe not certainly to this strength, but this has been going on all year and for the better part of last year. A significant shift in the equatorial Pacific temperature regime is well underway, classic signs of a major El Nino. And here's another way to view the scenario again, so we'll do it this way. Here's the date line running right up the middle. Time goes from past to present here with a forecast and all these different boxes. Some of it is the MJO, the black lines, and the reality is none of this MJO is really the MJO because the El Nino base state is strong. What we're really looking at is the colors here. Just like the previous chart we saw, the reds are westerly anomalies. Here is the major westerly wind burst that's currently going on right now, enhanced by the reds are an equatorial Rossby wave, a different type of wave. Rather than the MJO, which moves from west to east, these move from east to west. Anyway, when they interact with El Nino, an El Nino base state, they enhance westerly winds or westerly anomalies. The forecast for the next several weeks per this model suggests that, just like we thought about a week out, winds are going to start backing off associated with the westerly wind burst. We kind of just go into a light westerly wind regime, a little bit of a Rossby wave, and maybe some, they call it MJO, but it's not MJO. It's probably just an enhancement of the base state of El Nino. Continue to fuel westerly winds into November. And yet one more way to view this. Now this one's a little bit backwards. The past is here. The past is down here. The forecast is up at the top, so we look at it in reverse. Here's the major westerly wind burst that occurred in June, July. The yellows are westerly anomalies. Here's the current westerly wind burst in flight. We get a little bit of a break in late October, and then November, the whole month of November is pretty much dedicated to yet more westerly winds, fairly strong, maybe in the westerly wind burst category, but if not, at least anomalies. The interesting part here is up in the January time frame, more westerly winds are forecast, and notice the date line runs right up through here. And so at some point you'd expect like this to see the westerly winds start curving off to the east as El Nino matures. This model suggests that El Nino isn't going to be fully matured even on January 9th, and that westerly anomalies will still continue on the date line. We find that a little bit hard to believe, but we'll go with it for now. Anyway, overlay MJO activity. This is showing a active phase of the MJO here. We don't believe that. We go into a little bit of an inactive phase and then another active phase into January. And then equatorial Rossby waves, we'll actually do it this way. The interaction of the MJO, equatorial Rossby waves, is where you get the extra reds, the westerly wind bursts, just like down in here. Now, we have equatorial Rossby waves here helping to fuel westerly winds, but nothing significant. And then another interaction up here in the January time frame. And then finally, one more. This is the El Nino, they call it low pass here, but basically the number of contours here help identify the strength of El Nino. This chart suggests that El Nino is going to peak out in the late November timeframe, early December, and that would be about normal. Chronologically, that's typically how it goes. So that certainly puts this westerly wind burst in here in January sort of in doubt. But anyway, you get a sense of what the long-term projection is. More of the same, basically, which is pretty impressive. Next up, so we've talked about westerly winds on the equatorial Pacific. Those westerly winds, which would be like right here, help push warm water that's normally all pulled up over here off to the east. This image clearly indicates that a big pocket of 29 degrees Celsius water temperatures with a pocket of 30 pushing off, and we've been watching this, the edge here of the line, both the 28 degree isotherm is the classic one. We're watching this slowly working its way, about maybe a degree every 4 or 5 days off to the east. We've also watched the 28-degree isotherm line working its way off to the east, suggesting this giant pocket of warm water, which again normally would be back here, is continuing to work its way to the east. Classic El Nino. Now, here's the anomalies, differences in normal for this time of year. And clearly, we see a large this is the West Pacific here, this is the East Pacific here, this is the equator, a couple degrees either side of the equator, and down to depth, down to 300 meters. So a whole profile of the equatorial Pacific from west to east. And clearly we see much warmer than normal water. 7-degree anomalies poised off the Galapagos. The Galapagos are here, they're out over at about 90 degrees or so, like right about here. And you can see, of course, there's an array of buoys. That's how all this data is captured. The X's are sensors on the buoy anchor lines. We see this array is out. This array over here is out. Pieces of it are out. This is pretty much normal. NOAA's got to send ships the whole way across the Pacific Ocean to go fix this stuff, and it's scheduled, but we're not going to get a 100% picture. Anyway, the point being, major warmth in this area, 4, 5, 6, 7 degrees above normal, and this is the Kelvin wave number 3 made from the large westerly wind burst that occurred in June, July that we talked about. And now we have another westerly wind burst occurring right now in this area, more warm water falling to depth. Here's perhaps a better way to see it, updated October 5th, another sort of model view of what's going on subsurface. Here's our warm pocket that we saw with 6-degree anomalies or more. Actually, let's count them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Yep, 6-degree anomalies in pockets here, mostly in the 5-degree. This little guy here, this cool pocket, this is right up along the Ecuador coast, has reappeared again. This is kind of not surprising, really. We've talked some about the warm pool being west displaced. This is more evidence of that. Also notice here the 4-degree temperatures, the spike just barely touching the surface at about, what would that be, about 108 or so, 105, and we'll get into that in a minute. Just sort of keep that in your mind. But also notice this is 3-degree anomalies from about 145 west to about 100 west. So what you're going to see is, when we get into the surface data, that all the warm water that's erupting from this Kelvin wave is erupting in this area, and you can see literally on these little points where it's working its way up to the surface. The other good point here is westerly winds blowing this area. You can literally see, here's the date line, 175 west right here, warm water falling to depth. And this pocket, especially out in here, is growing significantly. The warm temperatures here they appear to be building to the west, but what really is happening is more warm water is filling in from the east, and it's backfilling into the back of Kelvin wave number 3. We're going to call this Kelvin wave number 4 out here, and you'll see why in a minute. And you've seen this chart before too. This is JSON-2 satellite data from October 5th. And basically, we strip out all the seas, all the tides, all the chop, everything, and we're looking for sea level differences from normal for this time of year. And these are in centimeters. A large pocket of 15 centimeter anomalies above normal. So what this means is warmer than normal water is at depth. Warm water expands, pushes the surface, makes a little bubble on the surface, a little bulge on the surface, and the satellite is so sensitive it can pick it up. So this is a proxy for saying there's a large amount of warm water under the equator. So we'll put this in, here's the deal. Westerly winds here, westerly wind burst, creates Kelvin wave falls to depth, and Kelvin wave is warmer than normal water, starts working its way off to the east. We can see that Kelvin wave, and then it starts erupting somewhere between Ecuador, the Galapagos, or maybe a little bit west of there. All this chart is basically saying is more evidence to support a massive Kelvin wave is below the equatorial Pacific in the east. And finally, our favorite chart, upper ocean heat anomalies. Again, a variation on the same thing, looking for warm water subsurface. We're going back in time. Again, past time is here, working its way down towards the present. And you can see a Kelvin wave last year. There was actually another one before it. This was the false start El Nino of 2014. Upwelling phase of the Kelvin wave cycle, a little bit of cool water off Ecuador, and then we got into this year. Boom, one Kelvin wave, strong one in the March time frame, very warm anomalies, 2.5 degree anomalies, another one in the May time frame, and then massive Kelvin wave number 3 here started. Remember the westerly winds that we were comparing in the late June, July time frame made a massive Kelvin wave that is now erupting into Ecuador. And now look at this little bit right here. Westerly winds from the 4th major westerly wind burst appear to be, and look at this here, these 2 degree anomalies backfilling all. So basically, and you can sort of see Kelvin wave, these little, when it nudges out here, Kelvin wave, Kelvin wave, Kelvin wave. Number 4 in flight is what it appears like. And remember, if it's just forming now, it'll take 2.5 months to make it to Ecuador. Okay, so that puts us in, let's see, middle of, let's say October to November to December, end of December, and then another month for it to go from here to advect into the Nino 3.4 region to start really having an effect on the atmosphere. So we're talking the end of January, early February, if this Kelvin wave is what it appears to be, that El Nino isn't going to just collapse and die in December, but could go significantly longer than that. Now, this speaks to the character of this El Nino. This El Nino has been slow, maddeningly slow in getting going. All the dynamics, all the data, whatever you say, looks great, but it's just taken a while for it to get going. You know, I mean, everyone's been saying major El Nino, significant El Nino, et cetera, but to see it manifest in the atmosphere, like when we were looking at the jet stream charts, yeah, the jet stream looks pretty good in the Gulf of Alaska, but it's nothing like over the top. The reason being, this is a slow building, steady El Nino, but slow building, and the presence of this 4th Kelvin wave suggests that this El Nino is going to peak later compared to, let's say, the 97 El Nino, maybe more like the 82, 83 El Nino. We can get into that in a minute. Anyway, so major Kelvin wave appears to be in development. That is the point. All right, so we've talked about westerly winds. We've talked about Kelvin waves. Multiples of them already have impacted, and the third is impacting now the coast of Ecuador and the Galapagos. And then when they gurgle up to the surface, it creates a warm pool here. This is what we're looking at. Sea surface temperatures, differences in normal for this time of year. And notice a major warm pool here extending from Ecuador the whole way out to the date line. Very warm. This is the low-res image. Also much warm water here off the U.S. West Coast. This is not related to El Nino. This is a different thing going on here related to a switch in the Pacific Decadal Oscillation, a 20 to 30 year cycle that runs in an inactive or an active state or cool and warm state. The thought is that the PDO is switching over to the warm state. That's sort of like the warm phase of the PDO is sort of like a 20 to 30 year, I wouldn't say an El Nino, but a environment more favorable for the development of El Nino, whereas the environment we've been in with the cool phase of the PDO since 97 through just recently has been in the cool state, and that has supported La Nina. And clearly, one can say since 97, we have not had great amounts of rain. We've not had great surf. We've been in a down phase. The thought is that might be changing, but that's not the topic for this evening. It is this warm area here, and we're going to dive into the details. But first, here is, how strong is this El Nino compared to anything else? We'll get into that, but just a quick look here. Here is our current one. Here's the 97 El Nino. 97, just right off the bat, you go stronger, much warmer. We're sort of looking here, how far to the south did the warm anomalies go? This is the 20-degree line here, right here in the Nino 1.2 region. And it's not as far to the south here at all, maybe down to 12 or 13, maybe 14 south. And not as concentrated in this area, but out here in the dateline region, it's a little bit cooler in the 97 event, where in the dateline in this event, 2015, it seems to be warmer. So the 97 event was very focused right in this area. This event seems to be a little bit more westward displaced. What does that mean? Well, we're not sure. We're not sure it really means anything, because the 82-83 El Nino, which was, so there's been two super El Ninos, 82-83 and 97-98. 97-98, this one, was very focused in this area, okay? The 82-83 El Nino was more focused out here. Yes, it had warm water here, but not as much as we have in 2015. It was really more completely westward displaced. The 2015 event, and the reason we're doing this comparison is the two super El Ninos we were talking about, 82-83, 97-98, and there's been talk that 2015 is going to be a super El Nino, and you know what? That's probably not idle chatter, given all what we're seeing right now. We're going to get into that. But the character of this event will not be like 82-83 or like 97, but somewhere halfway in between. 97 started early, flamed out early, and was gone. 82-83 started late and hung on forever. Based on what we were seeing about Kelvin wave number 4 just forming, we suspect this one's going to hang on for quite a while as well, which could be a good thing for precipitation, especially in the Sierra, especially in the April-May-ish time frame. Later in the winter, more precipitation. That would be a good thing. Here's the high-res view, 5K resolution versus 50K resolution. The point being, again, well-defined, but most of the warm pockets are here rather than over in this area. Again, this is why we're talking some about this being westward displaced, and good amounts of warm water out to about 155 and continuing almost to the dateline from there. If you hear talk about the blob warm water again off the U.S. West Coast, this is that PDO anomaly that we were talking about earlier. And then zooming in even more, we're looking at pockets of warm water. One pocket here, another one here, another here, a large one here with anomalies to, 5 degrees. Another one here, 1, 2, 3, 4, 5 pockets at least. Now let's go back in time just a little bit. September 25th, when the Kelvin wave first started erupting, more coverage you can see than what there is today. It kind of comes and goes. Currently we're in a reasonably active state, but most of the activity is clearly west of the Galapagos. That was the point of this. And just a real quick zoom here. Here's the look zoomed in off between the Galapagos and Ecuador. Sure, warming here, but nothing super warm. Not like it was earlier. Again, this is talking more about the westward displacement. Also, this little pocket of cool water has been here. It just won't die out. We've been waiting for it to disappear. It doesn't. We don't even care anymore. Here's the more zoomed-in view off to the west. This is all looking good. Right here, we've lost some warmth. This was solid a couple of days ago, the whole way off the end of the picture, kind of fading a little bit. And El Nino does that. The temperatures will wax and wane depending on a variety of conditions. And likewise, out to the dateline, this at one point was solid with 2.25 anomalies the whole way almost to the dateline. It has been fading again the past couple of days, not as impressive as it was earlier. Here's an index of water temperatures in the Nino 1.2 region. This is between the Galapagos and Ecuador, roughly. We had, and this speaks to, in the July time frame, water temperatures were 3 degrees above normal, and then they've steadily sort of dropped off. We got a little spike there, but basically, the majority of the focus doesn't seem to be in the Nino 1.2 area. It's warm, but again, this speaks to the westward displacement of this El Nino. And then finally, the Nino 3.4 region between 120 west and 170 west, almost to the dateline. This is the main area NOAA uses for classifying the strength of an El Nino. And so you can monitor the temperatures on a daily basis. Their current reading plus 2.2 degrees right here. We had an all-time spike at almost 2.5. It was like 2.45. Back, what was it, a week or so ago, a little bit more than that. Anyway, still temperatures very, very warm. So what's the point of warm water on the equator? between the date line and roughly the Galapagos Islands. Well, that warm water changes the jet stream configuration. It changes the atmospheric situation, not just in the Pacific, but across the entire planet. Okay? So what we want to do, and that's the whole point of El Nino and why one gets hyped up about it regarding surf in winter months relative to the North Pacific, because it fuels stronger, larger, and longer lasting storms than normal. That is, in La Nina years, you might get one-day swells. You might get a couple of them. During strong El Ninos, and take, for example, the 97 El Nino. The 97 El Nino, let's start with a normal winter. You'll get what we'll call 5 or 6 significant class swells of 20-foot Hawaiian, roughly. During the 97 El Nino, there were 36 significant swells, way above normal. This was a super El Nino. Okay, so that speaks to the bonding or the coupling of the ocean and the atmosphere, the effects on one another. So this index here, we're going to now start looking at how much is El Nino impacting the atmosphere. Okay, Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers represent either the active phase of the MJO or El Nino. When you start seeing minus 49s, that is a sign that a major El Nino is in play. When you see long-running, and we'll just go through the chart here, long-running negative numbers, that's a significant El Nino. The daily number, SOI index, minus 18.60, good place to be. The 30-day running average, the all-time peak recently was reached for this event, minus 22.72. This is a very good sign. Another very good sign, the 90-day running average. When it gets to minus 18 and hangs there, we start really getting interested. Minus 18.9. Very good. As long as these numbers stay in the minus, let's say, 20 range, this guy will continue to fall. Even if he just hangs at minus 18 for the next 2 to 3 months, that's all we need. We're perfectly happy, and we're going to say a major El Nino's in play. Another index, the ESPI index. This is a measure of precipitation basically over top of the Nino 3.4 region. This index, it's really interesting. They've charted ESPI and Nino 3.4 temperatures, and you can see here from the ESPI index that it spikes before Nino 3.4 temperatures do in just about every case here. So let's say the big 82, 83 El Nino, ESPI peaked out before the temperatures. Also the 97, 98 El Nino, same thing. Now here is something to really take note of. The ESPI index here and here, these are super El Ninos. Look where our ESPI index is. It has beat the current, or beat those previous two super El Nino indexes, and temperatures are still on the rise. And here's ESPI data for the 82, 83 super El Nino. Peak number 2.98 there in November. The 97 Super El Nino got to 3.54 with a string of threes, and that was in June. Here's the 2015 El Nino, 3.45, so very close to the June reading of 97, but a month later, and and there we go. We missed the August number, 2.45. We expect these numbers to actually continue to rise. And from this chart, the daily number, 2.22, it's basically been hanging in the 2 range the entire time or better. So again, it measures the difference in precipitation over this area versus over north of Australia. In fact, you can see it right there in this area here. This is exactly what the Southern Oscillation Index does, just on surface pressure. This does it on precipitation. And finally, sea surface temperatures compared to multiple El Ninos in the past. Here's where we are, 1.67. This was per the, I believe this was September data, 2015. Now, remember, we're still a ways from the peak. Other El Ninos that peaked out, the 65-66 El Nino, 1.87. The 72-73 at 2 degrees, 82-83 at 2.2, and the 97 El Nino at 2.32. But for this time of the year, September, the temperatures are warmer than any other time other than the 97-98 El Nino. And you can see here it flamed out kind of early. The 82-83 El Nino right here went on a bit longer. So we're going to be interested to see whether we can make this climb and get up into this super El Nino range. We think that is entirely possible. So the quick wrap up. North Pacific is coming online. South Pacific slowly shutting down. Another trough forecast for the North Pacific. Gale activity forecast. Multiple tropical systems of interest in the coming weeks. It looks like things are going to get very interesting. Regarding El Nino, big news. Major westerly wind burst in play. Kelvin wave number 4 appears to be developing. This is all very good news. This speaks to a building El Nino situation. All the indexes suggest that a super El Nino is in development. It is not at super El Nino status yet. We have a ways to go until Nino 3.4 temperatures get to that level, but things are looking very good. We suspect this will be a late starting El Nino. It'll take a little while to get going, but once it does, things will really get moving quickly. So make your preparations, continue training, make sure you got your quiver all set up, and get ready, because when the storm door opens, things are going to get wild and woolly and really quick. So that's it for this week. We'll do it again next week, same time, same channel. Enjoy. Thanks for watching.